Let's first recall the laws of exponents. If you have an expression raised to 1, then it's equal to the same expression. Any expression raised to 0 is equal to 1. If you have a negative exponent, rewrite the expression as a fraction with the numerator of 1 and the denominator with a positive exponent. If you have like terms, add the exponents. If you have a fraction where m is greater than or equal to n, then your answer is the expression with the exponent m minus n. But then if in your fraction n is greater than m, then your answer is a fraction with the numerator of 1 and in the denominator, the expression with the exponent n minus m. If you have a power of a power, then multiply the powers together. If you have a power of a product, then distribute the power into the terms. If you have a power of a quotient, then distribute the power into the numerator and to the denominator.
We have here 16 raised to negative 1/2. The first step is to make it a fraction, which gives us 1 over 16 raised to 1/2. Since it's 1/2, we have to get the square root of 16, giving us the final answer of 1/4. Example number 2, we have this. The first step is to remove the negative exponents by switching it to the other side of the fraction, giving us this. And you add like terms, which gives us 2a raised to 9 over 3b raised to 5. And now since we have this, we're going to square this part, giving us 2 squared a raised to 18 over 3 squared raised to b 10. And after that, we simplify it and giving us the answer of 4a raised to 18 over 9b raised to 10.
Problems like square root of 4 or cube root of 27 are really easy, since 4 is a perfect square and 27 is a perfect cube. Square root of 4 is equal to 2, while cube root of 27 is equal to 3. If you have a problem like square root of 24, it's not going to be as easy since 24 is not a perfect square. So what you do is you break it up into its factors. So that's 4 and 6. And since 4 is a perfect square, it becomes 2 square root of 6.
So our first example, we have to simplify this expression. Since 18 is not a perfect square, we break it up into its factors. So we break it up into 9 times 2, and then we can bring up x to the 5th into x to the 4th times x, and then we can retain y to the 4th as it is since it's already a perfect square, and then times z. Next, we bring 9 out of the radical, so we get 3. We can bring this out as well, so it's x squared, and we can bring this out. And then whatever that's left inside the radical, 2x z. And this is our final answer.
Now I'll be teaching you how to rationalize the denominator. We have here 5 over square root of 3. This is not yet simplified because we have a radical sign here in the denominator. So what we do is multiply it by square root of 3 over square root of 3, giving us 5 times square root of 3 over 3.
Now we have examples on how to rationalize the denominator. So first we have the cube root of 1/2. Multiply the numerator and the denominator with the cube root of 4 to rationalize the denominator. Our final answer will be the cube root of 4 over 2. So our second problem is the cube root of 1/2. This is the same as the cube root of 1 over the cube root of 2. Now the cube root of 1 is equal to 1, and then we have cube root of 2. So to remove the cube root in the denominator, we multiply the expression with the cube root of 2 squared over cube root of 2 squared, since we need to get a perfect cube. So this will give us the cube root of 4 over the cube root of 8. So we have the cube root of 4 over the cube root of 8 is equal to 2. So this is our final answer. Our last problem is 2 over 5 plus the square root of 3. So to simplify this expression, we need to multiply it with the conjugate of 5 plus the square root of 3, which is 5 minus the square root of 3 over 5 minus the square root of 3. So the conjugate means it's the same terms except one is plus and one is minus. So we multiply the numerators, and then to multiply this, first we need to square the first term. So 5 times 5 is equal to 25. And then square the last term, so the square root of 3 squared is equal to 3. Then we put a minus in between. So distribute 2, so we get 10 minus 2 square root of 3 all over 22. And since they're all divisible by 2, we can still simplify this. So our final answer would be 5 minus the square root of 3 over 11.
Okay, now we're going to learn multiplication of radicals. This is the formula that we're going to use. Nth root of A times the nth root of B equals nth root of AB. The first example, we have 3 plus square root of 5 squared. So what we do is, we square the first term, we square the last term, and we multiply the two terms and multiply it by 2. So 2 okay, now square this, then square this, 5, and this will become 6 square root of 5. Add like terms, giving us 14 plus 6 square root of 5. Second example, we have square root of 6x times square root of 5y. So what we do is copy the radical sign and multiply 6x and 5y, giving us 30x 5. Example number 3, we have 5 plus square root of a times 5 minus square root of a. So what we do is square the first term, put the minus sign, and square the last term, giving us 25 minus 8.